Good evening, friends. Welcome to Eastern Academy. We are discussing about microprocessor in our embedded system programming session, and we are into session 2 now. And in the last session, session 1, we are given a small introduction about the microprocessor. Go slow, very nothing. If you don't understand, ask me always in WhatsApp or our next session. So we have enough time to understand. So go through the videos, since all the recorded videos are available to you. You can always go through it and find out where you don't understand. And that's why I given a time between one session to other session 1 or 2 days. It's because I want you to understand this session thoroughly before you come to next session. We are not in a hurry. Okay, next. The beauty of this session is a very clear. We're going to discuss about all the three: machine language, assembly language, and high level language. How these things are working. Okay, so what are the people have all the doubt? They ask me that, hey, what is the difference between C+ and C++, Python, and why can't I use Python in embedded? Why we are using C in embedded? What is assembly language? What is machine language? All those things. They all quite simpler concept. Okay, so and that is what we are going to at the end of this session. We're going to achieve this. Okay, so let us go back to the our board. As I told you that I'm quite familiar with boards rather than PowerPoint. So in the last session, we discussed about thing very clear. The microprocessor does two activities. One is with the outside memory. It can write and it can read. Am I right? Then it has a small registers. That's what people get confused. This is a small memory only. Okay. Then it has a process unit. And it talks to the outside world with address, read, write, and data. There are only 4 sets of wires. We assume this is 10. We assumed, and it can be any number. 8. It can be any number. We are taking right now 8. And we have discussed everything. But the beauty is, it knows how to do things. But who is doing all these things? There's a beautiful unit called control unit. We call simply CU, control unit. That guy is the one who controls all these things. Here there's another unit called bus interface unit. Forget about this, right now not required. And now this control unit gives this command. Please hear, the control unit is a control. So your register and the bus and what has to go on address wires, the read signal, write signal, data, everything is controlled by who? The control unit. Based on what? Based on this has from outside. He gets a command from outside. Let us take it once again. I remove this so many wires. I put a single wire. 8 wires. See that? It's a one direction. 8 wires means 2 power 8, 256. That means that he understands everything by a command. Number. If you tell him 45, he does one operation. If you give him 75, he will do another operation. Please understand, this is 8 wires means it is from 0, 0, 0, 0, 1, 1, 1, 1. This is 0, this is 255. That's it, nothing great about it. So, somebody you tell him 45 plus 36, you're going to tell him same thing. But unfortunately, he does not understand plus. So you will tell him plus 45, 76. But this manufacturer this microprocessor manufacturer could have given you a table. A table. In the table, addition means 12. Subtraction means 13. Like that. Like let us say in English. Okay, in English we say go. In Hindi we say ja. Am I right? So what is the relation? You need to have a dictionary. If somebody comes to the India, then they have to do that. If somebody comes to Tamil Nadu, then they have to learn about English to Tamil. If you go to Andhra, then you have to go English to Telugu. That dictionary has, so this table is nothing but a dictionary given by the manufacturer. Not ASCII. Please, it's not ASCII. ASCII I'll discuss later. It's not ASCII. This is a just number. There's no standard. ASCII is a standard. Here there's no standard. This is there are two worlds. Let us assume that. I know only Telugu. And you know only Hindi. Gone. We cannot discuss. Am I right? I have only Telugu, you have Hindi. I cannot discuss. So there is somebody in between who knows both Telugu and Hindi, created a table, a book called dictionary that contains every Telugu word, the equivalent Hindi word. Okay, so I read the Telugu, then I learn Hindi. That's the way I do that. Now, here same thing. There are n number of microprocessor manufacturers. For example, there's a company called Intel. There's a company called Microchip. There's a company called ARM. There's a company called RISC-V. There are a lot of companies are manufacturing the microprocessor. Each one is having their own language. For example, in Intel, 12 means addition. In ARM, 12 means multiplication. In Microchip, 12 means subtraction. Where in RISC-V, 12 means division. Could be. Understand? The 12 does not same. Each one have a different language. So what happened? When you use a specific microprocessor, you have to give a table. This table is called instruction set. So each microprocessor manufacturer gives you the table for every instruction. There is a operation code. They call op code. Call operation code. That means addition. 41. Subtraction. 25. So like you have a language. In your language, for every operation you have it. For example, go means go. Okay, ja is a go in English. Then come. For every your activity, there is a specific word. Here, for every activity, there is a number. But there also one beauty is there. See here. This guy never get confused. See, if I say add R0 and R1, put the result in R2. For that, there is a number. I can say add R1, R2, R5. There is a number. I may say store R0, 700. There is a number. But 700, there is no number. But our store R0 is having. When I say load R0, there is a number. Understand? So, for every activity, there is a number. That number has to be given to him. You know, the moment you give the number, he will do it. If you tell him that 12, he knows what to do. Understand now? So let us do a small program. Let us do a small command. I wanted to add two numbers, 45 plus 76. Okay. What I do here is I say move R0, 45. This is one type of instruction. I'm moving 45 to R0. I say move 76 to, move R1 to 76. I say add R0, R1 into R2. That is done. Understand? Now what I do is immediately after this, after writing this, I go to the table. Forget about this. I can write here. I can use this place for a table. Instruction set. Okay. So here I have two columns. One is instruction, another is opcode. First one is move R0. Other one is move R1. Other one is add R0, R1, R2. Okay. For this, this company could have produced 21, 22, and 45. Now what I do here is I convert this into move R0 means 21. 21, 45. Then move R1 means 22. 22, 76. Add R0, R1, R2, 45. Understand? This cryptic language is called assembly language. Why they use the word assembly? It is because those days when this was invented about 100 years back and all, those days, the very famous was mechanical assembly machines. There, when you wanted to assemble a car or bike or whatever it is, they will give you like this cryptic instructions. That's why they call this as a assembly language. You will do one by one. That's why they call this as a, after this, next assembly. That's why they call this as a assembly language. It's a very, very cryptic word. Move, add, load, store, everything. And this is called machine language. But the problem here is I stored 45 and 76. But very unfortunately, if I use once again R0, R1, this will get erased. So what people thought, I don't want to do that. I want to store it in the memory. Now let us remove this because I have dictionary about instruction set. I store it in the memory. So I have a memory. In the memory, I have 3 locations. Let us assume that this location is called 1000, 1001, 1002. I have 3 locations. I wanted to store the first number in 1001. In 1002, I add and put the result in 1002. That means that I put a bracket means value. 1000 means if you put within bracket, that means that at 1000. So I'm reading from 1000, maybe 71. Then 1001. Put the result in 1002. Now let us see that how to write the small command step for that. Okay. Now I write the same thing. Please try to see. I'm telling you now once again, you may not 100% understand what I'm discussing now. Go back, watch the video once or twice. If you don't get it, that's why I am giving you the recorded one to you at that night itself. After this class, I'm uploading recorded by about 10 o'clock because you can view it another time. 2-3 times you will observe it. Still, if you don't get it, ask me. You can tell me that I don't understand this. I'll explain to you in the next class or immediately on the WhatsApp itself. Now, see here, 71 and 45, I want to add. So 45 and 36, the previous one we take. 45 and 36, I want to add. See here, move I write it same thing as we discussed. Move R0, 45. Store R0, 1000. Now you see that one extra thing I added. I'm storing it here. So now I move it to 45 to R0, then I'm moving it to 1000. Then I say move R0, 36. Store R0, 1001. I'm moving it here. Then I say load R0, 1000. Load R1, 1001. Add R0, R1, R2. And store R2 into 1002. Do you understand this? If you don't understand this, ask me where you don't understand. If you don't understand now, you tell me where you don't understand, please. I wanted to store a number 45 at 1000. I told you I cannot store. The microprocessor can move only from register to memory. That's why I have moved to register, then I'm moving it. Now I refer the instruction table. Okay. In the instruction table, for every instruction, move R0. There's an instruction. There's an instruction called store R0. And there's an instruction called load R0. There's one more called load R1. Then add R0, R1, store R2. Load R0, R1, sorry, not load, add R2. Understand? This, for each one, you have a different number, 41, 42, 31, 32, 35. And 71, whatever it is. That don't tell me what is his number. These are all given by the microprocessor manufacturer. There's a table they themselves have given. Now what I do here, I convert this move R0 into 41 and 45. Store R0 42,000. Then move R0 41. Then store R0 42. Then load R0 31. Load R1 32. You are actually translating. You are using a dictionary and translating. There's nothing great stuff for anything. Load R1 32,001. Then add 71. Store R2 35. So what I have done, I have converted this assembly using this table. I converted to this machine. And I give one by one to this microprocessor. He is going to do that. Next, we will see how we are giving one by one. That is the next concept. There's a next concept. First of all, you should know this. That means that if I want microprocessor to do some activity, I should write on this language. And I will convert it and give it to that. Is it clear? But here is a problem. This one, the assembly, is not same for every microprocessor. If you use Intel and you move it to the this one, if you move from Intel to ARM, then you have to learn the assembly of ARM. Then you have to move from ARM to microchip. You have to learn. Every company have their own set of, like I move from Chennai to Germany. I have to learn German. If I have to move to French, I have to move French. That's why, fortunately, we have now a common language all over the world. Most people speak is English. Am I right? So that's the reason English have boomed all over the world, because of a common language. Like that here. It's a big problem. What is a common language? So what people are trying to find was this. I have a, see here, I have an Intel microprocessor. Intel microprocessor. I have an ARM microprocessor. I have a Atmel microprocessor. For example, I have 3 companies we take. Now each company is having their own assembly language. They have their own instruction set. They are different. All of them are different. So what happened? You have to write a own assembly language. So this program, okay, it will be different for all the 3 people. They are not same. But what people have did is very beautiful thing. Okay, what they have done was they have asked you to write a single high-level language. High-level language. Understand? But this is only one, not 3. But I use different translators to translate it into this one. This is what you call it as these 3 are called compiler. This is called Intel compiler. This is called ARM compiler. This is called Atmel compiler. They convert your high-level language, either C or C++ or Java, whatever it is. They are getting converted to irrespective of the assembly language, and then they refer the instruction set, and this is assembly language. Understand now? So you write on C, but that is getting converted to different compiler. So you cannot use the same compiler. Okay, that means that I will have a translator who will translate from English to Hindi. I have a translator who translates from English to Tamil. I have a translator who translates from English to Telugu. Am I right? So yes, I cannot use the same translator to translate it for other people. How come? I don't understand this one. My instruction set does not work. Am I right? So that is a trick. Is it clear? If you have this board, if you are not clear, let me know, please. If you are not clear on this board, let me know. This is a very critical discussion. That's why today we are not using any of this assembly language. We expect, because every company is using different processor, you have to move. That's why we always advise you to use the high-level language. Then we will discuss about what is the different high-level language, why we are using it. Okay, first of all, try to understand this. Slightly maybe going over your head, but don't worry. Go and watch the video once again. You will understand it. Correct. You are right. That is called assembler. There is a software called assembler. There is software called assembler. The assembler will convert from an instruction set to this. This is, now we automate this. There is a software called assembler. We are going to write in our course. In our course, you will be writing an assembler program yourself. I will teach you how to do that. In our C programming, there's application. Everybody is writing a assembler. You can write assembler. Either you can do manually. Let's say in your college, in your microprocessor lab, you will do manually. But here we are going to teach you how to write your own assembler such a way that you convert this to this by your program. But understand one thing, the microprocessor understands only machine language. The microprocessor never understands assembly language. He understands only machine language. So if you write the Python or Java, it doesn't matter. All the things are getting converted to assembly, then going in. If you don't convert it to assembly, then how do you use the instruction set? It is not possible. Without assembly, I cannot get into the machine language. Please understand. So any top level language need to be converted to assembly language to getting into the machine language. Please understand that. Okay. Now, by saying this, I'll tell you some important thing now. Let us write a small program in C. Let us write a small program in C. I say char ABC and A equal to 45, B equal to 36, C is equal to A plus B. I've written a very small program in C. I give this to the compiler. Now, what the compiler does, yes, he will take the first line. You have written character ABC. The compiler creates a table. The table, he puts your ABC. It gives the address 1000, 1001. This is called symbol table. Symbol table. Please understand, converting every symbol to address. For you it is symbol. For the computer, for the microprocessor, everything is number. Then it takes the second line. A equal to, A is what? 1000. That means that the compiler takes the second line and convert it to move R0, 45, then store R0, 1000. That is nothing but A. That is nothing but A. Am I right? That is A. I'll write it in different color. You know that. So 1000 is A. Then it takes the second line. It takes the second line. B equal to 36. So what it does, it converts move R0, 36, store R0, 1001. That is nothing but B. Then you are doing now A plus B. You are adding. So what is the A? He is reading now. He is reading the A now. Load R0, 1000 because 1000 is A. Then he is reading B. Load R1, 1001. Then you are adding. Then it performs add R0, R1 and put the result in R2. Then you are, after completing the addition, you are storing it in C. What is C? 1002. You put store R2 into 1002, which is nothing but C. This is A, this is B. Now, do you get it now? What I have written here, this program and this program are same, which is nothing but I use the compiler to compile it. So this machine code, when you write a C code, this is what generated in the machine code. This is, but every symbol what you create, the compiler is creating a memory location for that. That is called symbol table. All are same. We have instruction table to convert. So this is what this table explains everything to you. This table, this one page, this board. If you understand this board, you understand everything. If you don't understand, ask me where you don't understand. You be very clear. Let us say this is 1, C. Okay, this is 1. We'll let us number one by one. This is 1. This is 2. This is 3. This is also 3. Both are same. Both are same. So we call 3. This is 4. Sorry, this is 4. Instruction table. This is 5. Last one. So there are 5 steps. I write in C. After C, I create a symbol table. Then I converted C to assembly. Then assembly, I can refer an instruction table. Then I create a machine number. So if you don't know, if you have some problem in the 5 steps, let me know that which step you have a problem, 1 to 2 or 2 to 3 or 3 to 4 or 4 to 5. That's it. Once you understand this, I will tell you how the microprocessor is executing this. That's it. Then you know that if you write a C program, how the microprocessor is executing that. That's it. Perfect. Somebody's have doubt. 4 to 5. Yeah. That's actually 4. It's not 4 to 5. It is 3 to 5. When I say here in 3, very good. That's a perfect thing. Somebody asked a thing, they have a doubt in 4 to 5. See, move R0. This is the assembly instruction. I go and refer the table. This is 41. I write the 41 here. Then the 45 is an operand. So if you write here 7 plus 3, the plus is the operation, and 7 and 3 are called operand. You don't change the operand. You just change only the operation. Now you say store R0 here. That is the operation. Store R0 means 42. I've written here 42 to 42. But the trick here is that has operands of 1000. So I put 1000. 2 bytes. Then move R0. That is the operation. Move R0 is once again 41. I store 41. Then 36. I write operand. So I don't change the operands. I convert only the operations with the numbers. I don't touch the operands. Operands are same numbers. But you write A, but that becomes 1000 because of symbol table. The compiler give every of your variable there is a symbol. Understand? Thanks. That's all. Yeah, you are perfectly right. Somebody has asked very clear. Please don't write direct message. Then I have to repeat the message to everybody. He has asked the thing. Here R0, R1 are internal register and 1000, 1000 and 1002 are external memory. So perfect. That's a perfect understanding. So this is what I love. Even you understand, please write it and ask me that if my understanding is correct. That is best. Okay. I can now itself say that, but please understand one thing. I don't expect you to understand this in 50 minutes. Okay. That is why I have given it 2 reasons. One is I made this as a video and give it to you. You can watch it at your home, aram se, any number of times. Also, I have support you WhatsApp. You can say that at this in the video at this much minute, 55th minute, I don't understand. You can go to the you can pause it and take a screenshot and send it to me. I don't understand this. That's why people do it. Okay. The best way is that learn how to interact with me on WhatsApp. I'm ready to support you. I told you beginning itself. I want you to understand this. But the beauty is, you'll be very surprised. Tomorrow when I'm discussing about ARM, everything you will understand, because this is a principle working in all the microprocessors, irrespective of 8085 to Core i9. All are same. Please understand. Nothing has happened big way. But it's a very, very simple. See, you study the great mathematics, calculus, integral, so many things. Compared to that, this is nothing, man. Please think of a minute. What you tell me here, what you don't understand, I'm ready to explain. But the beauty here is this has to go to your memory very strongly. This will help you a lot. I will tell you later. Maybe coming days, you will understand thoroughly. Now, I'm not worried about C anymore because I know that if you write in C, it get you symbol table and convert to the assembly. I'm not worried. Then I'm not worried about the instruction table, the thing. Then assembly, I'm not worried. Now I'm worried only one thing. How I converted this. Then how this microprocessor execute. So what I have done is this finally, the last step. What we do here is inside the memory, which accepts only one byte. In the memory, you have only 1 byte, not multiple bytes. There's only 1 byte. Then you write here 41. This. Then 45. Then 42. 10. 00. 41. 36. 42. I'll tell later how do I go, how I'm going to write. This is happening on my computer, how it is going to memory. I'll discuss later this one. Right now, we assume that I'm writing into the memory one by one. 42, 10, 01. Then 31, 10, 00, 1000. Then 32, 1001. I have some more. Okay, let's write everything. Then 71. 35, 10, 02. If you see here, in this one, this is operand. 41 is operand, operation. And this is operand. This is 42 is operation. And these two are operands. And 41 is operation. And this 36 is operand. 42 is operation. And this is operands. Operation. Operands. Operation. Operands. Operation. Operation. Operands. Understand? These are all operation. These are all operands. Okay. Understand? Okay. Is it clear? Now I remove this because I store it on memory. Now what we do here, I have a microprocessor. I have a control unit. This control unit, if you give a 5 volt to the microprocessor, it is giving the address. This is floating at 00, first one. It goes 1, 0, 1, 0, 2, 0, 3 like that. If you say here, this control unit will give the address 00 first. So the microprocessor on giving a power on gives the first address is 00. It will do read. It will give write as 0, read as 1. And it looks for data because it's giving read. At 0041, the memory will give the 41 here. It goes to control unit. Control unit understand, hey, 41 means move R0. He understands. The control unit intelligence is this. He understands that 41 means move, understand. You say that. If I tell you jar, okay, you know move. Am I right? That's a way. You need not have to know about go. Okay, that's the same thing here. You understand go, then you walk. The same thing here. Same way, because this is his language. You may not understand 41, but he will understand 41. But he knows that move R0 means what to move. If I tell you that add, you say you tell your servant, hey, go to shop and buy. Then he will ask you what to buy, sir. Here, same thing. You tell him move R0, but what? Then the control unit will give the address 1 and take the 45 and give it here. Then he stored it on the R0, 45. You understand? This microprocessor automatically gives the control unit. That's what is built. That is the beauty of the control unit. Now first instruction is done. Then he takes 42. 42 means he knows that store. He knows that. This is language. You may not understand this. Please understand. Because you don't understand that, don't get... See, I don't know Telugu, man. I don't know Telugu. I know only Tamil or English. I write in English and translate it to Telugu and give it to a Telugu person. He will understand that. Doesn't mean that I have to understand. But you have to make sure that you write in English. If you start getting confused how that guy is going to read on Telugu, that is his problem, man. He knows Telugu is his mother tongue. If you don't understand, that is his problem. Okay, you know English. The same thing. You write in C. You write in C that car A, B, C. A equal to 36. A equal to 45. B equal to 36. C is equal to A plus B. You better do your job. You don't worry about this. You do better your job in English. You see, whatever it is, Python. When I get converted to the compiler, and the compiler will getting into assembly language, the assembler will convert it to binary by machine language. Assembler, then that game will execute. Don't worry about this. That is what your problem. Your problem is always worrying about unwanted things. I explained to you that the whole thing, the process. Understand? If you wanted to go in depth of it, I will give you. Already I have an app. I have an app in the App Store, but I will also give you. Try to. I don't know right now how to make it as a free, because I tie up with somebody. I don't know how to make it as a free. Once I make it as a free, I'll give you. We can watch it. I want to make something to our students that is a free, where I've explained that how the microprocessor works thoroughly internally. Okay, thoroughly internally how the microprocessor works. I know that. I know thoroughly. I've designed the microprocessor. You may not believe it. In '83, when I was studying in the college, BE third year. Okay, it could be remote college. Think of it. 1983. You don't have any online. You don't have internet. Nothing. We have designed the full microprocessor using breadboards in the lab, using TTL chips. Such a level we did it. Okay, so don't confuse this. It is, you go and watch, think, write it on paper. You write your own program, write it on paper. Otherwise, I have taken a course for the students about 8085 already. I can share. If anybody wanted to tell me no, I will share the 8085 course to you. Assembly language, programming. You will understand thoroughly. But we are in embedded system programming. I am not going to touch assembly language. I will touch only C. Okay. Here we are not going to confuse about assembly, because today nobody is interested. No company is very much interested in assembly. Everybody wanted to test your only C knowledge, and you want to do only C. Now, it's a very important thing you have to understand. That is a trick. People used to ask me that, what is the difference between C and C++ and Java and Python? Am I right? That everybody will have a thing. The trick is that when I write it on C, same code, adding two numbers. The thing is add two numbers and store. Store, that is X is equal to A plus B, or C is equal to A plus B. If I do it on C program, I compile it. It gets assembly. When I put on C++, I compile it. That gets working assembly. When I put it Java, I compile it. It gets assembly. In Python, I compile it, I get assembly. From assembly, I get converted to machine language. Understand? Please. What is the difference here is this. When I write it on C, this will convert only few assembly instructions. You do C++, that guy will convert more instructions. So your code become very big. If you say this is about, let us say, assume that 20 bytes. This will become 40 bytes. If you do it in Java, if you do it on compiler, it will be about 100 bytes. If you do it on Python, that may produce 200 bytes. Now, Python is producing more number of code for the same operation. C is producing less number of code. Then why I have to use Python? The thing is that if we're given a task, if I write it on code in C, if it takes 1 month, if I do it on C++, I can do it on 15 days. If I do it on Java, I may do it on 10 days or 5 days. If you do it on Python, I'll do it on 1 day. Understand? Let us say I want to travel from Chennai to Delhi. I can walk, or I can go by car, I can go by train, or I can go by air flight. But the problem is the confusion. I cannot use all the time all. Understand? You walk within your house. You cannot use a flight within your house. Understand? That means that wherever I want very high speed, I want the microprocessor to execute things faster, I'll go C. That is one other thing is electronics. In electronics, everything is speed. So please understand the difference between electronics and computing. When I use in computer, I'm not worried about the speed. I'm worried about only execution. I want to do things faster. That time I go for Python. But when I do the same thing in electronics, I want everything to be very fast. That time I will go for C. Understand? That's why in electronics, that is in the embedded world, we don't use Python, we use only C. Whereas in all your artificial intelligence, computing everywhere, I cannot do it in C. It'll take, if I write a program in Python, I can do it 1 or 2 days. If we do it on C, it'll take months together. Actually, which companies don't want. Understood? So we will discuss on the next session how the codes are taking more time. I have to explain about something called clock. Once I explain about clock, you'll be able to understand the whole thing. Okay. I think fairly I've given you a small idea today. I think whatever I tried my best to give you that at least the top level, this is called bird view. Now you should know that what is microprocessor, what it does, how you're going to use it. You're going to drive a car. Am I right? That is what all about this microprocessor. This is a very, very, very top level thing, what you should know. Okay, I'll explain to you about the clock next session. And another session is the one, how this guy is talking to various devices. That's the beauty. That how this guy is talking to various devices. That once you understand, you're done. Fairly, you will know that how I'm using a microprocessor to do multiple activities. Okay. You can ask me of any doubts if you have it.